Good morning all. In last class we discussed about the basic introductory concepts of electric vehicles. In today's session we are going to see about the electric vehicle configurations and electric vehicle layouts in which the roles and responsibilities of electric vehicle components can be realized. In this class, we will see about the electric vehicles configurations which comes under the course outcome 1 says about layout of electric vehicle, system components and electronic control system, under which lesson outcome 1 is to discuss about the layout of an electric vehicle, under which the specific outcome 2 says about the understand the layout of an electric vehicle. So here we will see it about the electric vehicle configurations, electric vehicle layout and electric vehicle components and their roles one by one. So in electric vehicle configuration, it comprises electric propulsion subsystem, energy source subsystem and the auxiliary subsystem. The electric propulsion subsystem consists of vehicle controller, power electronics converter, electric motor, mechanical transmission system to which electric wheels have been attached. In energy source subsystem, it consists of energy management unit, energy source, energy refueling unit. In auxiliary subsystem, it consists of auxiliary power supply, hotel climate control unit, power steering unit. So first we will see it about the electric propulsion system. So based upon the control input received from this brake pedal and the accelerated pedal, the vehicle controller fed the input to the power electronic converters. The power electronic converter receives the input from the vehicle controller and convert that input into the conditioned and controlled electrical signal and provide them as an output. So this conditioned and controlled electrical signal will be fed to the electric motor, so which the speed of the electric motor can be regulated. Since this electric motor and the mechanical transmission system are coupled with each other, then the mechanical transmission system can successfully operate the wheels of the electric vehicles. So suppose when this electric motor runs above the rated speed, then this electric motor acts as a electric generator. This generated power is called as a regenerated power. So this regenerated power can be stored in the EV batteries, electric vehicle batteries, ultra capacitors or the super capacitors, as they have the capability to store the regenerative power. So next unit is the energy source subsystem. Here the energy management unit will cooperate completely with the vehicle controller to control the regenerative action. And this energy management unit will also work with the energy refueling unit to control the energy refueling unit effectively. And this energy management unit will constantly monitor with the availability of the energy sources. So next unit is the auxiliary subsystem. In auxiliary subsystem, the different voltage level is obtained in order to power up them to the power steering unit, auxiliary power steering unit and the hotel climate control unit. So this is what about the configuration of the electric vehicle. Next one is the electric vehicle layout. in electric vehicle layout. This is the electric grid system. This is the level 1 charger. This is the level 2 charger. This is the level 3 charger. And this structure is the and this structure is the electric vehicle drive system. So here, based upon the need of the electric vehicle, this charging level, either the level 1 or level 2 or level 3 can be chosen. This so here what happens, this electric grid will supply the electrical power to the battery pack, electrical power to the battery pack through the charge battery charger or the charge regulator. And we know that in the battery it contains only the DC energy. I mean, it stores only the DC energy. Hence, this battery charger converts the AC and electrical supply into the DC form to store the electrical energy in the battery. So this battery pack consists of the battery modules, coolant systems and the battery management systems. So this is an electric motor or a traction motor. This is a AC type motor. So we know that the battery output will be the DC. So that has to be converted into the conditioned and controlled AC output by means of the power electronic inverter systems. So this power electronic inverter system will feed the conditioned and controlled AC signal to the electric motor. So this is the mechanical transmission systems. So as they coupled with the electric motor, it can be successfully operating the wheels of the electric vehicles. So this is the DC to DC converter or the chopper, which will power up the peripheral devices of the electric vehicles. So this is what the idea here. This electric vehicle will act as a source. This electric vehicle will act as a load when the grid is supplying the electricity to the electric vehicle. This electric vehicle act as a load when the electric grid is supplying the electric power to this electric vehicle. So when the electric motor runs above the rated speed, then there is this electric motor act as a generator, and this generator will generate the electric power that is called as regenerative power. So this regenerative power is stored inside the battery by converting the AC into the DC. And after its storage, then it can be converted into the converter, and it can be converted from DC into the AC before the AC supply is fed into the electric grid systems. So in this case, this electric vehicle will act as a source to the electric grid system, because this electric vehicle is supplying the electrical power to the electric grid system. Next. So these are all the major components of the electric vehicle. They are the battery pack. So this is the battery pack. This battery pack consists of the coolant system, battery management system, and the battery modules. So the types of batteries are used in the electric vehicle are the lithium ion battery, lead acid battery, nickel metal hydride battery. So among them, lithium ion battery is most preferable batteries. So EV chargers are the level 1 charger, level 2 charger, level 3 charger. So based upon the need of charging level of this battery, this charging level, this charger, the type of charger, EV charger, can be chosen by this electric vehicle. So for suppose if there is a quick charging is required for this electric vehicle means, then it will go for the level 3 charger. It is a super fasting charger. So anyhow, this will be seen as a separate topic in forthcoming class. So next one is the battery management system. So this battery management system is used to monitor the performance of the battery modules and used to control the operating performance of the battery within the safety operating range or within the safety operating limits. Next is the energy source for the electric vehicles. The available form of energy source for the electric vehicles are the renewable energy sources like the solar power, wind power, and geothermal power, hydroelectric power likewise. So this is the power electronic converters. So we know that power electronic converters, this is a rectifier or battery charger, and this is an inverter, power electronic inverter. So this power electronic converters or controllers are used to condition the electric signal and control the electric signal and applied to the electric drive motor in order to regulate the speed of the electric drive motor. So that is the role of the power electronics converter or the controller. Next one is the electric drive motor. So electric drive motor can be chosen based upon the high starting torque. Based upon its high starting torques, the electric drive motors can be chosen. Next one is the transmission unit. This transmission unit will be coupled with the electric drive motors for effectively operating the wheels of the electric vehicles. So these are all the major components of the electric vehicles.